Welcome back, everyone. So we're going to start session 4, our fourth and final session of the day. Thanks for hanging in, guys. I'm happy to introduce our first speaker of the last session, Robert Pivar. He's with the Long Point Walsingham Forest Pollinating Insect, his presentation is Long Point Walsingham Forest Pollinating Insect Monitoring. Robert is a biologist with the environmental consulting firm Natural Resource Solutions Incorporated. He's a trained entomologist, having received a Ph.D. from the University of Tennessee, and has extensive experience in insect taxonomy and systematics. His main area of interest lies in understanding insect biodiversity, both locally and abroad. So welcome to Robert.
Hello, everybody. Thank you for sticking around for a presentation today. So I'll give you a brief outline about what I'm going to talk to you about today. I'll give you an intro about myself, some of our objectives, methods, what we found so far, and some preliminary conclusions with the data that we've collected. And then I'll show you where we're going to go in the future with this work as well. So you've already heard a bit about me. Graduated from the University of Guelph with my Bachelor's of Science in Environmental Science. Worked at Niagara College for a bit, taught a course there. Then I went to the University of Tennessee to do my master's and Ph.D. After I completed that, I had some time at the Smithsonian in Washington, actually during my Ph.D., worked there for a bit, and then taught at Brock. And now I'm at Natural Resource Solutions doing consulting, and it's been great. Still get to play with bugs, which is a lot of fun. So this project came to fruition when the Canadian Wildlife Service released their Integrated Conservation Action Plan, and they identified that fire suppression was actually a pretty big threat to open country habitats such as tallgrass prairie and savanna habitats. So NRSI was awarded funding so we can address and implement some conservation actions, and one of those actions was actually to look at pollinator populations and to see how prescribed burns can affect the abundance, richness, and diversity of these populations, where prescribed burning was proposed. We've heard a lot about pollinators today, so I don't think I really have to explain any more about them to you, but they're really important, obviously, for our food and also for the food of wildlife and healthy ecosystems and plant reproduction. And for our project, we focus on 3 insect groups for pollination. We focus on butterflies, wasps, bees, and the true flies, Diptera, which are my favorite. And there's some smiling faces too, which is always exciting when people are excited about flies. So we've got 3 properties that we looked at with this project. We've got over here the butterfly block. This is next to Bacchus Woods, Demare Home Farm, and Manister Tract, which many people are familiar with in the audience. The butterfly block and Demare Home Farm were both previously agricultural usage. In 2010, that usage stopped, and these were actually replanted with tallgrass prairie seed mixes, and they're run by the NCC currently. Manister Tract up here has no history of agriculture as far as I know, and it's currently provincial crown land, and it's managed by Ontario Parks and the St. Williams Conservation Reserve. So within all these plots, we've got 6 monitoring plots in each one, totaling 18 monitoring plots. So all these plots have a recent burn history, which I've outlined here. In the butterfly block, block number 5 was burned in 2021, 1, 2, and 3 burned in 2020, and then block 4 up here hasn't been burned yet, although this past year, the NCC removed some of the invasive pines that were present in that area. For Demare Home Farm, the nearly entire plot was burnt in 2022. Actually, this is the first experience I had in tallgrass prairie, so when I walked out initially, I could see the grass, right? I was like, wow, that is tall grass. As I got closer and then I got into the grass, I was like, wow, this is tall grass. I was blown away. That was my first experience in a tall grass habitat, and it was pretty cool and kind of nerve-wracking, kind of like lurking through the grass, looking for your pan traps or whatever. Who knows what was out there? And then in Manister Tract, as I said, this is a naturalized area that has no history of agriculture. And you can see here there was a prescribed burn in 2022. And this is by far my favorite property to visit just because it's so cool. It's so peaceful in there too. And I always seem to run into people randomly, like interesting people. Like I can't remember the guy's name who's presenting tomorrow. I ran into him, Canada's Indiana Jones. I ran into him. That was pretty neat. Anyway, so methods. What's going on with our research here? So our monitoring plots are about 50 by 50 meters in size. And we use 3 different types of survey methods. We use visual surveys. So basically, you're observing all the plants in the area in your plot. If you see a pollinator come through and maybe land on a plant, you would record that. So if a butterfly lands on a flower and it starts nectaring, you say, okay, butterfly, monarch, nectaring. If something just flies through the plot, you would record that as well. They could be mating, just resting on a plant. You record all pollinator species that you see, their behavior, and any plant interactions. The second survey is sweep netting, which consists of essentially doing a kind of a random transect throughout the plot with your net, sweeping 50 times, sticking your head in and seeing what you found. As far as pollinators go, I find it's not as effective for collecting pollinators, but you do catch a ton of spiders and grasshoppers, so when you stick your face in there, you're immediately covered in all these jumping insects on your face. And then pan trapping, which is probably the most effective method for pollinator sampling. We had 21 pans, 7 yellow, 7 blue, and 7 white to replicate flower coloration. And we'd fill these with soapy water, leave them out for as long as possible, typically 5 to 8 hours. Usually it's a weather-dependent thing. So these are a couple of our plots in Manister Tract. We're doing some visual surveys here. This is our typical X pattern for our pan traps. I find that with the X pattern, you cover the most ground, but also it's the easiest to relocate your pans, because when you're in those tall grass habitats, if you kind of randomly scatter your pans all over, good luck finding those again and retracing your steps. I've dropped a couple things out there and never found them again. Surveys we did once a month at each site from June to September for a total of 72 collecting events. And for identifications, we perform them in the field when possible to family or genus and sometimes species. And then for the pan traps, because those samples are so large, we would collect those, bring them back to the office, and then we'd actually get Gregory from the University of Guelph, who's really great at IDing insects down to pretty well the species level for the most part. He does all of our identifications for us. So for the results, these results are more of a general overview of what we found so far to date. It's more encompassing all 3 properties rather than more site-specific results. And they don't include any samples from this year, 2023. Those are still being identified. But we've got data here from 2019 to 2022. And then plots 1 to 6 that you'll see in the next few slides are all butterfly block, 1 to 12, Demer Farm, and then 13 to 18 are the Manister Tract. So when looking at relative pollinator abundance, so basically the number of individual pollinators that you're seeing, you can see that Manister Tract by far has the most abundance, the highest number of individuals, followed by butterfly block and Demer Farm. And then when we start taking burns into account is where we start seeing some more interesting data. So if the plot has not been burned yet, you can see that we have higher abundance, especially within Manister Tract. Whereas with burned plots, you'll see that we have less abundance, although there are some aberrations there as well. And we'll dive a bit more into this information. So this is pollinator abundance encompassing all the pollinators, Hymenoptera, Lepidoptera, and Diptera. So if you look here, years since burn, no burn, obviously there's been no burn. 0 years, those are years where there's been a burn and we actually collect that same year. 1 year since burn, 2 years since burn, that's pretty straightforward. So when looking at no burn, you can see that in Manister Tract, you're getting very high abundance still. And with no burn in butterfly block and Demer Home Farm, your abundance numbers are actually kind of low, And when you have your first burn, if you've collected that same year, the numbers are about the same, but then after year 1 and year 2, you're starting to see a rebound in pollinator numbers. So breaking it down now by order. So Hymenoptera, your bees and your wasps. Again, Manastar, very high abundance despite there not being any burns yet. Except for the one site where there has been a burn, they still have a fairly high number of specimens being collected. And then if you look at butterfly block, Demer home farm, does that beeper mean 15 minutes? Okay. If you look here, you'll see that numbers with no burn are fairly low. 0 years since burn, still kind of low, and then also another increase. Similar story with Lepidoptera. Manastar tract, again, high abundance numbers despite no burn. Funny here is that when you do have no burn, Lepidoptera numbers are kind of high, actually. And then once you have 0 years since burn, the numbers drop, and then they'll start to rebound after your first year and second year of sampling. And I did not do any crazy time travel here. That's just a typo. Syrphidae abundance. So syrphids, the first couple years, we didn't really look at them too much, and over the last 2 years, I've been pulling them out of the samples a bit more. So our data here is kind of not as complete, but over this year and next year, hopefully we'll get some more syrphid data. Sorry, syrphid folks, but we're going to help you out, don't worry. And then looking at diversity now, so the number of species within these plots. If you look at years since or no burn, fairly high for bees and wasps, especially in Manastar tract. Interestingly, in the butterfly block, these numbers are quite low. And then after their first year, so if you're collecting the same year as a burn, those numbers stay low. But again, you start to see that rebound after your first year and your second year. Similar to Lepidoptera, except with Lepidoptera, almost across the board with no burn, you see these higher populations or higher diversity of Lepidoptera. Then you have your first burn, first year since burn, those numbers will drop, and then they'll start to increase again. So as far as the species go that we found both introduced and native species. I don't have any numbers yet to say like X% are native, X% are introduced, but that's something that we'll certainly look at in the future. There are no tallgrass specific species. They're mostly all generalist species that we've collected. But this is just pollinators, mind you, right? There's still other taxa out there that could be specific to tallgrass prairies. We just haven't been sampling those species. But that would be interesting to look at in the future as well. And nearly all of the species are considered to be common or secure within Ontario, except, of course, for monarch, which is special concern species. But it's nice to report that the second most abundant species in all these plots, as far as butterflies go, are actually monarchs. And 13 out of the 18 plots, we see them very regularly. Unfortunately, the most common is the cabotuit. So some conclusions for now. These are preliminary, of course. Relative pollinator abundance and diversity are generally higher in plots that are not burned, whereas the lowest abundance and diversity are areas that have received a burn that same year as collection. Which makes sense, right? That's what you would expect. If you just burned an area, you wouldn't expect there to be very abundant and diverse pollinator populations there. They're going to drop, but they will increase over time, which we've seen so far and which is consistent with previous studies. So other studies indicate that for Hymenoptera, for example, bees and wasps, within 2 years, you start to see a nice rebound in population size and diversity. And with Lepidoptera, it takes about 3 years, but you do see those increases. Which is one reason why we want to continue these studies, because we've only done about 2-3 years of collecting. So we want to continue to make sure we can see the full rebound. And it also illustrates that doing these burns, despite the initial effects of population falls and population drops, they're still important to the ecosystem. So you do these burns, you'll see a drop, but then in a few years you will see that rebound and they actually become more diverse and more abundant in the future. And then when we were looking at our plots, as you probably saw in the results, Manastar tract is by far has the highest abundance of pollinators and the most diversity as well. And the lowest are in Demer home farm. And this is also to be expected given that Demer home farm and butterfly block have a past of agricultural use, whereas Manastar tract does not. So it has had the ability to build up these populations and diversity over the years. So moving forward, 2023, we just finished our sampling in September, and that's all being identified now by Gregory. 2024 will be our last year of field surveys, and then in 2025, we're going to do a more robust analysis of the data, really dig into these trends and see what we can find. And as well, we want to hopefully get a couple of publications out of this. And then we also, so NRSI released this year, I believe it was, best management practices for tallgrass, prairie, and burning. And one of those sections, chapters in that publication was that dealing with insects. So we want to see if we can use these practices and tie them into what we found so far with our research. So for example, if you have a rare species in a habitat, you don't want to burn the entire habitat, maybe burn just 25% of it. Or if a nearby habitat is overgrown, burn that habitat, and then these rare species can hopefully move in there in the future. Or sometimes maybe burning isn't even necessary at all. So for example, if you have a rare species that's in a very small patch of habitat, it might be best to avoid burning so you don't wipe out that population and maybe use some other techniques to help restore that habitat. And yeah, I'd like to thank ECCC for their funding and all these other organizations for their funding as well. And Emily, Gregory, and Maya for their help in the field and identifications. And with that, thank you all for listening, and I would love to answer some questions if you have any.
Thank you very much. Are there any questions? Anyone want to ask a question? You'll have to come up here. Please come up here.
You're getting your steps in today. Wonderful.
Awesome talk.
Thank you.
I had a question. I might have actually missed this, but can you kind of figure out whether there's a sweet spot in terms of the frequency of burn? So I'm thinking about the intermediate disturbance hypothesis, right. And yeah, can you actually parse that out with your data set?
I'm hoping we can. I don't know yet. I haven't really looked into that, but that's definitely on our list of things to look at in the future. So hopefully next year or the year after, we'll come back here and I'll have some answers for you.
That's awesome. Thank you.
Yeah, thank you.
Is there anyone else? Okay.
I'm wondering if you have observed on the sites that have been burned or have been restored, if you're noticing an increase over time. I realize it's a pretty short time span that it's been sampled, but could you, in theory, predict like when they might reach that reference site state?
So so within a property, for example.
Yeah, if a site has been restored, about how long might it take, or is it ever going to reach a reference site that hasn't, had that agricultural history in terms of pollinator diversity?
That's a great question. I'm not really sure of the answer to that, but I think, if we're just comparing the burned sites with the unburned sites, so some of the data actually shows that beyond 4 years, you'll hit like a plateau in your abundance and diversity. And then after these burns, it drops and then builds up again. So I wonder if we'll see something like that, but I'm not sure of a time frame specifically addressing like an unburned versus burned site and how long it will take to recolonize that.
Okay, thank you very much.
Thanks, everybody.
Thanks for your presentation. Okay. Dr. Marnie Isaac is a professor in the Department of Physical and Environmental Sciences and the Department of Global Development Studies at the University of Toronto. She holds the Canada Research Chair in Agroecosystem Development and is the co-director of the University of Toronto's Sustainable Food and Farming Futures Cluster, leads an interdisciplinary research lab that explores plant-soil interactions, nutrient cycles, and ecosystem functions in diversified agroecosystems and the social processes that lead to agroecological transitions. So welcome, Dr. Isaac.
Thank you. Thanks. Can you hear me okay? Good for you guys? Okay. Like the speaker group before me, thank you so much for sticking it out till now, the end of the day on Friday, so thanks so much. I feel like a bit of an anomaly here because I have no nice photos of amphibians or insects in my talk. I'm really sorry about that. But for any of you out here that's interested in agricultural land restoration, plant diversity, and soil health, this talk is for you. So we're going to focus on that for the next 15 minutes or so. Andreas Rollhauser is a postdoctoral fellow in my research group. He couldn't be here today, so I'm really honored today to be here to give you this talk. As was mentioned, my research group at the University of Toronto really focuses on the role of biodiversity in agricultural landscapes and the impact on plant-soil interactions, nutrient cycles, and functioning of systems. We really do this in systems all around the world. We focus a lot in the tropics as well as temperate regions. But we're really interested in various types of biodiversity. This can be everything from functional diversity, so how plants function on the landscape, straight taxonomic diversity, so the amount of species, and also genetic diversity. So we really focus on all these types of diversity. But we can pretty much broadly say that enhancing biodiversity in agricultural landscapes leads to a whole suite of ecosystem services. We know that enhancing biodiversity can give us regulating services like carbon storage, pest and disease control. It can offer a diversity of crop portfolios and yield stability. And it can also provide supporting services like nutrient and water cycling and soil health. And of course, this diversity has been recognized here in Ontario. Alice, in the early 2000s, recognized this by introducing land restoration practices that enhanced biodiversity in marginal agricultural lands, which I'll speak about today. 2009, we saw agroforestry, so trees in agricultural landscapes, listed as a best management practice in Ontario. And even this year, in the national scale, the Sustainable Agricultural Strategy has identified biodiversity as a key focus area. This, of course, isn't only happening in Canada. This is happening around the world. And most recently, we had the publication of 13 principles to achieve sustainability in agricultural landscapes. And one of those key principles is the enhancement of biodiversity in agricultural landscapes. We can see that right here in this diagram as a key agroecological principle. This was identified by the Food and Agriculture Organization of the United Nations a few years ago, and now this idea of agroecology and biodiversity in agricultural landscapes has made its way into the most recent IPCC, and even here in Canada, during our assessment of biodiversity in agricultural landscapes, we see this as a really important factor, but totally understudied. So this is where we're at now. And the type of biodiversity I want to talk about today is called associated biodiversity. This is the type of biodiversity you see in agricultural fields at the edges. And this is a really understudied aspect of enhancing biodiversity in agricultural landscapes. We actually don't know much about this type of biodiversity. And even all these policies and practices that I mentioned also don't recognize the role of this biodiversity in landscape restoration. And I think it's here that this talk intersects with a lot of the talks today. When we think about agricultural land restoration, what is the role of this biodiversity in enhancing these ecosystem services? So this is what we were interested in, and so we reached out to Alice Norfolk, and they kindly connected us to a suite of farmers in Norfolk County who had various established patches of biodiversity in their landscapes. So we saw everything from edges planted with various tall grass prairie plants and different tree species. We had restoration practices happening on the edges of farms, and even here at the edge overlooking the lake. So we used this suite of farms, and we identified in these farms what we're calling transitional features. So areas of the landscape that are marginal on the farm that have been transitioned into these biodiversity plantings. And we wanted to understand the role of those in conferring some of these ecosystem services. So the main things we were interested in studying were aspects of soil health, recycling properties of the soil, and input reductions. And we used various proxies to understand these three phenomena. We measured active soil carbon as a proxy for soil health. We measured microbial communities as a proxy for nutrient recycling, and we measured total root biomass as a measure of input reduction. And so we went out into these suite of farms. Kindly landowners let us come out, take some samples, and also measured all the biodiversity in these plots. So we measured taxonomic diversity as well as the functional diversity in these plots and took soil samples. Here's some of our results. What we did here is compare forested landscapes to those in agricultural production to those that have been restored. So we have on the bottom graph here, forest under agricultural production and in grassland restoration. And what you can see here clearly is that we get a rebound in soil carbon with this restoration. So it drops down from forested to agricultural and then rebounds in these grasslands, which is great. We're seeing an impact of this grassland restoration on very critical processes in the soil, such as active carbon, which is very sensitive to these management practices. Similarly, if we look at these cover types, forest, agriculture, and grassland, and we look at the total root biomass at these sites, we see this rebound or recovery happening in these grassland sites. We would expect this. We know this, that as we enhance this biodiversity, we're seeing these soil processes recover. Now, this is where I'm going to take a little bit of a twist, and hopefully you guys can follow along with me, and I explain it clearly enough, but even though we're interested in these processes in land restoration, simply measuring biodiversity and soil processes is not enough. It doesn't actually allow us to understand why this is happening. And that's really what we're interested in. We want to understand the various pathways where we can get from restoring land as an intervention to these outputs. We're interested in adding complexity or nuance in the pathways that go from enhanced biodiversity to these ecosystem services. And so to do this, we create these pathway analyses that go between enhancement of restored landscapes through soil properties and also plant traits. And these plant traits are what are moderating the outcomes of these processes. So let me just walk you through this really quickly. When we want to be able to do this, we want to go from the environmental conditions and the management to the outputs. But the pathway is not direct. That pathway is moderated by how plants grow and their traits, which then control all of these processes in the soil. So we go from these environmental conditions at a site through the expression of these plant traits in these communities, in these plant communities, that act as levers on these processes in the soil that then produce the outcomes that we're interested in. And it's this complexity that we were interested in understanding at these sites in Norfolk County to be able to contribute more nuanced idea of how the plant community is actually producing these outcomes. So if we go here, I'm showing again the graph I first showed, and we can see the forested site has the higher active carbon, it drops down, and then it rebounds in the grassland, restored grassland. But what we want to do is add this complexity. So let me walk you through this. Here is that pathways I just showed you, and now here is the data to show us all these pathways. This looks complicated. The main point that comes out here is that this outcome of soil carbon is being completely controlled by leaf traits in that plant community. So as those ecological strategies of the plant community shift from agricultural crops to these restored landscapes, we see a controlling or moderating factor of, for instance here, leaf dry matter content or leaf mass per area. These are specific traits of these plants that are controlling the output of this soil carbon. So while there is a clear pathway between these soil properties, there's also a moderating pathway between the actual traits of these plant communities and these environmental outcomes. Understanding these pathways allows us to specifically select plants and traits of plants to enhance this land restoration. Similarly, if we look here at root biomass, as I showed you before, we can just measure this outcome and these land management practices, or we can enhance and understand the complexity of the pathways that go from that management practices to the outcome. And that goes through these moderating traits. And these moderating traits here are leaf area and leaf mass per area. This indicates the type of plants that are most controlling these outcomes of these soil properties. This allows us to identify specific plant traits or taxonomic groups that will enhance these important ecosystem services. And I'll point out here that in these studies, some of these outputs were actually non-native species that controlled these soil processes. And so we're seeing a trade-off between different outcomes that we're interested in, whether it is the enhancement of native species or the enhancement of soil health. And we need to make decisions about what output we're most interested in because these plant communities control these outputs. So the overall implications show that this restoration of agricultural lands can help achieve these agroecological principles of soil health and input reduction. This we have undoubtedly shown. So farmers who are transitioning marginal land into biodiverse perennial plantings are enhancing these ecosystem services and these soil properties. This is undoubted and has been measured. And that this is through the promotion of specific traits of those perennial vegetation. We can feed this information of those traits back into seed selection and selection of plant communities for these types of land restoration. What we also show is that we really need to disentangle some of these interactions, to go beyond thinking about managing landscapes and outcomes and really focus on the mechanisms that are driving those outcomes so we can get a good sense about how to appropriately manage these outcomes and the importance of considering these multiple pathways for restoration. So with that, I thank you. Of course, we had some funders for this research, and I want a deep gratitude to the farmers who participated. Some of them are here in the audience. Thank you so much for letting us take samples, and thank you all very much.
Thank you very much, Dr. Isaac. Is there questions from the audience? Please come up.
Thanks for that.
Yeah, no problem.
Could you go back a slide showing your fundamental graph of the three different scenarios? That one right there.
This one? Yep.
I'm not going to argue or disagree with your analyses over there, but you never mentioned that in scenario C of actual cropland, it's undergoing twice a year maceration, herbicides. It's destroying the seed, destroying the seed bank, destroying the root matrix, everything. And you didn't mention how those physical factors alone could explain that graph without necessarily going into the complexity you're putting over there.
No, it's a great question. So this complexity over here is just for the grassland restoration. This is where we're seeing the impacts of those traits moderating those outcomes. You're right. What you've just explained completely describes this drop right here. We know that. Tillage is aerating the soil. We're losing carbon. That is explaining that process. We're interested in understanding when you add plants from here to here, what traits enhance this jump? What explains that jump? I hope that answered your question.
I can't come up with, can you hear me?
Yeah.
Okay, so my big question is, what types, because I'm not a farmer, so I don't really know other than trees and orchards, what kind of perennial plants would a farmer be planting?
Okay, so just the
That would
question.
enhance the land.
Yeah, repeat it. What type of plants would farmers be planting? Perennial plants. So this is associated biodiversity. So this is biodiversity that's occurring at the edges of farms on marginal land that is being taken out of production.
Oh, so it's not gonna
Yeah, it's a great question because understanding the integration of biodiversity into production is a whole other area and super interesting. But this is trying to understand what happens when you have a marginal piece of agricultural land, you want to restore it. What is it about those plant communities that are contributing to these outcomes like soil health?
Okay.
Anything else?
I don't see anyone else coming up for a question, so thank you very much. And we'll
Thanks.
move on to the last speaker of the day. Our final speaker of the day, Gavin Mayberry, has over 10 years of project management and consulting experience, providing professional services for commercial construction, transportation, infrastructure, and land development projects. His specialized experience includes compliance monitoring for construction projects in and around provincially significant wetlands and environmentally sensitive areas, as well as the supervision and technical evaluation of natural channel realignments and aquatic habitat offsetting designs. Gavin has spent the last 3 years heavily focused on the sustainable delivery of projects involving species at risk across Ontario. Welcome, Gavin.
Thank you. Hope you can hear me all right. Again, I'm not sure what I did to deserve the closeout spot here, but I'm very thankful for everyone's attendance here today. So as it was said, I'm a consulting biologist working for Lee Consulting Limited, and I'm here today to talk to you about the replacement of the Long Point Causeway Bridge, and that's specifically from an adaptive management perspective of a consultant and the challenges that go into a project of that complexity. So I want to first start off by acknowledging some of our project partners. It definitely took a village on this specific project. This is not everyone involved, but these are certainly the major players. Norfolk County, the contractor Sierra Construction, who specialize in bridge replacement and rehabilitation within environmentally sensitive areas and the management of those projects, as well as ourselves, the environmental consultant on the project, Lee Consulting Limited. We've been in operation since 1953. We're a Canadian-based, employee-owned company. We participate in planning, design, and construction administration, and we opened our environmental team in 2019. We're a diverse selection of environmental planners, biologists, ecologists, and excess soil specialists. We work across a variety of different practice areas from transportation to land development, as well as in construction support for a project such as this. This QR code here will reappear toward the end of our presentation, but that could take you to a story map featuring a whole variety of our work across the province with descriptive bios and what we're doing, where we're doing, and how. So for anyone unfamiliar with the Long Point Causeway, the project location, it is the lower portion of Highway 59. It is the only physical connection providing vehicular access to the Long Point Peninsula from the mainland. It's approximately 3.6 kilometers long. And the existing environment is incredibly complex. Long Point Causeway is adjacent to the Big Creek National Wildlife Area, which is in itself a component of the Long Point World Biosphere Reserve. It encompasses 771 hectares, predominantly of wetland habitat, but this is habitat that is federally recognized and protected for over 21 provincially and federal protected species at risk. So the existing causeway was constructed, if you're unfamiliar, in 1957. Current pavement conditions and deterioration have resulted in very narrow shoulder widths. And in general, the entire causeway fell drastically below current safety and design parameters and standards. The Big Creek Bridge, which you can see up here in this photo here, was constructed in 1959. It was a 7-span timber deck on pile structure. And it was deemed in 2016 to be in need of major rehabilitations within the next 1 to 5 years. You can see that in 2018, we didn't get there. Emergency repairs had to be completed in response to a significant amount of deck deflection in this very aged structure. And so this certainly pushed the process for the replacement and rehabilitation of the causeway along. The existing causeway itself is itself a physical barrier to the movement of a variety of wildlife species throughout these wetland habitats. We have an abundance of basking and nesting reptiles, including species at risk, which utilize the road platform itself for a variety of life purposes. Certainly the soft substrates are attractive for nesting turtles, and the paved surfaces are attractive to all reptiles as a form of thermoregulation site. Unfortunately, this has contributed to the Long Point Causeway being a known hotspot for road mortality, especially for species at risk. As early as 1970, researchers were estimating that as many as 10,000 animals per year were being killed as a result of direct road mortality in just this 3.5-kilometer section of the causeway. The Long Point Causeway Improvement Project came along and vastly improved the chances for local wildlife in the past by incorporating open grate ACO tunnels, which are effectively eco-passages for wildlife to move beneath the highway platform, as well as upsizing concrete box culverts for drainage and maintaining a navigation window between the existing Big Creek Bridge, which allows for wildlife movement. Other measures put in place were static signage and digital signage to basically educate motorists onto the risks of the causeway and the wildlife present, as well as exclusion fencing, which was installed in the margins of the wetland area alongside of the causeway. So with a project that is this large and this complex, an EA was undertaken in 2019 by Parsons to determine what, if any, measures could be undertaken to replace this causeway safely. Basically, they used this EA to create a long and short list of design alternatives to evaluate the scale and duration of impacts from replacement and rehabilitation activities within this area. And from that, they determined that the preferred design alternative actually involved shifting the entire causeway 7 meters to the west to allow for a staged construction schedule, which basically allows them to complete all of the construction activities required while maintaining a singular lane of vehicular traffic down to the Long Point Peninsula at all times. Now, as you can imagine, with all of these species at risk and all of the federal and provincial protections, project approvals, permits, and authorizations were numerous. And we acquired approvals, permits, and authorizations under the Species at Risk Act, specific to federally protected species, the Endangered Species Act, specific to provincially protected species, both aquatic and terrestrial, as well as work involving habitat remediation and offsetting, which involved the Conservation Authorities Act, Long Point Region Conservation Authority, and the Canadian Wildlife Act, which governs all work occurring within national wildlife areas. So ahead of this project, the County of Norfolk really set this project off on the good foot, and they did so in a variety of ways, but one of those was incorporating innovative ideas into the tender itself. And one of those innovative ideas was the requirement for individual references and experience forms for environmental specialists and qualified biologists on the project. Now, this is contrary to a lot of commonplace tenders in the construction industry, in which the consulting firm and or the company is evaluated as a whole. In this case, they were very specific that they wanted the right people on the job with the right level and mix of competency, specialization, and experience. The other thing that they did was include a special provision here for the development of an environmental management plan. Now, this environmental management plan is intended to be a one-stop resource for all of the environmental concerns and regulations that are going to be involved with the process of this undertaking. And the idea with an environmental management plan, specifically with this project, was that it would be a living document. It would be an effort in collaboration between both ourselves, Lee Consulting as environmental consultants, and the contractor Sierra to deliver the best product at all times and ensure that we can deliver this project with as minimal adverse impacts to the local environment as possible. So the development of this plan, it's a comprehensive document, as I said. It includes all of our permit approval requirements as well as hard copies therein. It also includes site-specific conditions and staging operations for every aspect of this bridge replacement. There is a plan in place that is to be followed to the letter. It also outlines changes in design and protection for environmental sensitivities in the lieu of any unforeseen changes that might be required. One of the most important aspects of this environmental management plan, and I think one of the aspects that made this project as successful from a consultant's perspective as it was the requirement for environmental awareness and competency training for every person who stepped foot on site. That included heavy equipment operators, delivery drivers, surveyors, you name it. If you were attending the site in any way, shape, or form professionally associated with this project, you would undergo an hour, unfortunately most of the time it was myself or another, an hour of species at risk training. And at the end of this species at risk training, it would highlight which species are involved with this project, acute and chronic sensitivities within the area, as well as outlines of protocols for things like encounters or incidental observations, And by passing some of the agency and the responsibility for environmental protection onto the individuals involved with this project, we're really able to have them adapt a sense of ownership. And I think ultimately this was critical in the delivery of a project of this scale in a complex environment with as minimal impacts as we saw. We also developed environmental checklists for everyday inspections, as well as a series of protocols for incidental reporting from things like spills to wildlife encounters. So as a consultant on a project like this, we have 4 main objectives. We're hoping to reduce species at risk and general wildlife mortality through the course of construction, mitigate adverse impacts related to wildlife habitat related to construction, reduce human-wildlife encounters, as well as maintain ecological connection and avoid phenological disruptions. So not only are we intent on kind of limiting our impacts, but we also want to maintain as great a sense of normalcy for the resident species within these very sensitive ecosystems as we can. So some of the innovative ideas that came forth and were put into place with this causeway design and replacement was the use of large steel sheet piles for wildlife exclusion. Traditionally, this might be used something like a geofabric textile fence would be used, but in this case, large steel sheet piles ranging from 16 to 25 feet were constructed and fabricated on site with these proprietary leg and support systems, and they provided us a great deal of flexibility to work in these environments. One of the best best design considerations here is that these were modular. We could pick them up and adapt them, adapt the footprints of excluded areas as well as the intent of those exclusions based around the work that was occurring during the schedule of the project. The other benefit to these is because they're large rigid structures, we were actually able to place them within the marsh area itself, utilizing heavy equipment from the road platform, which actually reduced a lot of encroachment and incursion into the wetland by what would traditionally be heavy equipment and labor crews to install physical fencing to exclude wildlife. Now around the bridge site, obviously these were not going to be suitable solutions, so we enacted a multi-barrier approach. We included wildlife netting beneath the bridge to limit nesting birds, turbidity curtains to isolate our in-water work areas and enable us to remove aquatic species at risk, and as well as silt fence barriers along the edges of the shoulders, which not only provided us additional exclusion measures, but also helped to prevent any contamination from the construction works from entering these wetlands. Eventually, and the sheet pile cofferdams were installed around the bridge abutments to facilitate construction. We had an overwhelming occurrence of species at risk during the carrying out of this project. We had historic evidence and active evidence of nesting eastern fox snakes within the existing bridge abutments, bridge structure, and just general associate area. I have never seen so many occur in one area, and we were kind of at a wealth of species at risk. We also have a lot of evidence of basking Blandings turtles, which are provincially protected, and they would be found only meters outside of our construction zone. We also had historic evidence of nesting barn swallows on the Big Creek Bridge itself. And part of our efforts out there to limit impacts to SAR was the identification and delineation of turtle nests through the causeway. As I'd stated before, we have a lot of soft shoulder areas, and it was a wealth of nesting materials for these native turtle species. So our ecologists and our monitors would sweep the entire length of the project on a daily basis, looking for primary and secondary evidence of turtle nesting. When this was found, they would delineate these areas and effectively establish a protection buffer from all construction-related activities to prevent any further disturbance to resident populations. We also had collaboration with other partners, including EcoCare International, which was a federally funded project to monitor road mortality, which helped us to inform our own records of what species were present, what species were getting into the excluded work area and where, and also potentially what species are more susceptible to road mortality in these areas than others. So as a component, and with all of these species at risk involved, fish and wildlife relocation was a major feature in the environmental management plan and the conducting or the carryout of the bridge replacement. Fish salvage and relocation occurred in numerous times, and this was generally done in a stepwise, project-oriented fashion. We also handled wildlife relocation, including species at risk. These were completed during daily sweep activities. If a wildlife was encountered, they were very gently encouraged to leave the work area, and if they could not be, they would be relocated on an as-needed basis. These relocations were heavily controlled by our permits and authorizations from our legislative partners, and they outlined everything from protocols and procedures for capture, handle, relocation, as well as rehabilitation of individuals, and then permit compliance and review. So pending any of these activities, summary reports had to be submitted to the regulatory bodies as well as all project partners so that everyone could be kept as up to date as possible on the presence and occurrence of these species within an active construction zone. We also want to thank our Indigenous partners for their participation. They provided us periodic monitors throughout the length of the process who would also work with our ecologists to identify potential environmental sensitivities or risk points. There was also archaeological and cultural considerations with excavation off of the causeway, as well as the in-water work areas. And in one of our efforts, Smith Marsh Habitat Compensation, we did actually find archaeological evidence of Indigenous settlements in the form of historical net anchors just off of the main channel. So a lot of challenges in a project with this many moving pieces, one of which was the nature and location of the causeway itself. It's a very narrow stretch of road, very narrow shoulders, which often meant that wildlife that could find their way into the excluded zone had a very difficult time finding their way out, and were often in very close proximity to active construction activities, as well as vehicular traffic, which was maintained. We had persistent environmental factors like wind and shifting water levels, which played havoc with our sediment fencing and some of our soft exclusion measures. We also had burrowing muskrats every day, which I'm convinced are nature's greatest saboteur because they can create a hole in anything. Private roads and driveways was obviously the greatest challenge. Amongst the bridge site, we were unable to fully exclude the work area because we had to provide access to all of the residents, the roads, and the private structures in those areas. And unfortunately, those openings in our exclusion measures also correlated with increases in wildlife activity, observations, and non-SAR road mortality. And that is not just related to the openings in the exclusion measures, but it was great because we had so many people stop while we were out there working, and we received so much anecdotal evidence from residents and longtime visitors to Long Point of these existing structures, be they outbuildings, historical foundations, being used by a wide variety of wildlife species for life processes from nesting to hibernaculum to just general habitation. Within Big Creek itself was a very challenging environment. It's subject to reversing flows. So based on offshore wind conditions in the bay, the Big Creek can be flowing out to the bay in the morning, and then by the time you've eaten lunch, it is flowing back into the marsh. And this wreaked absolute havoc with our turbidity curtains, which are effectively floating curtains within the water column anchored to the bottom of the channel. The currents in Big Creek are incredibly strong, and this unfortunately often led to breaches and detachment in our anchoring systems, which unfortunately often leads to delays in project scheduling to re-isolate these areas and accommodate additional wildlife removals. In total, we completed over 370 daily inspections over the course of construction, and we had a lot of coordination with contract administration and regulators, to communicate concerns specific to our permitting and authorizations. The key takeaway from this is that for a variety of factors, from inclement weather to the availability and delivery of materials, construction schedules can be very variable, fluid entities. Provincial and federal permitting windows are not, and then often for good reason. But this is definitely a case where we adapt the work to the authorization and permit requirements and what is ecologically sound versus adapting our environmental practices to the work at hand. In the end of the day, we shared all of these inspection reports and wildlife encounter reports with any interested party, including project partners and legislative bodies. So due to the shift of the causeway 7 meters to the west, we were going to permanently alter a great deal of federally protected species at risk habitat. This area specifically includes critical habitat for 4 recognized aquatic species at risk, and that necessitated off-site compensation. We compensated habitat in 3 specific areas: the Hahn Marsh, the Smith Marsh, and the Hastings Marsh. In the Hahn Marsh, 2,732 square meters of wetland habitat enhancement took place. This was predominantly achieved by digging a 400 meter by 8 meter channel between connected pond bodies within the marsh. In the Smith Marsh, 5,638 square meters of wetland habitat enhancement took place, again with the creation of a new wildlife pond with purpose-built wildlife features integrated into it. And in Hastings Marsh, we enhanced 4,157 square meters of wetland habitat, again by digging channels connecting existing bodies of open water. The goal with this habitat enhancement was actually to increase the amount of open water habitat within these marsh units, as well as increasing the general level of habitat diversity and connectivity within the marshes. Through all stages of habitat compensation, daily monitoring and species at risk sweeps were conducted. We also had daily reporting on not only the wildlife encounters, but the activity progress. And this involved us working closely with the local contractor and Canadian Wildlife Services to make sure that not only was the habitat being compensated appropriately as per the construction drawings and agreed upon permits, but that it was also moving within schedules that would allow us to meet permit deadlines. One of the great takeaways and finished products of the causeway rehabilitation was the inclusion of permanent exclusion fencing. There was exclusion fencing in the original design, but there were very quickly constructability and maintenance issues identified by the contractor, and they had done a phenomenal job all the way through the process in being proactive and addressing these issues before they became problems. So a redesign was completed with input from a technical consultant, and then as you can see, the finished product here, the exclusion fencing was finalized in the spring of this year with major construction works ending in the fall of 2022. These new exclusion fencing, they integrate the existing eco passages, and we've also introduced escape ramp structures for turtles and reptiles and amphibians. This is an effective one-way door which will allow wildlife species trapped within the work zone to effectively exit on their own accord at regular intervals into the marsh habitat on either side. So ultimately, this was an incredibly complex project from an ecological perspective, and it was a very novel one in terms of how many species that were federally and provincially protected were involved, not just potentially present, but observed on a daily basis. And we have to accredit the vision of Norfolk County to begin with. They ensured that the proper resources were allocated for these environmental protection services before boots ever hit the ground. This was not an afterthought, and they were really proactive in ensuring that this project was achieved with as minimal adverse environmental impacts as possible. We also focused heavily on collaboration with all our project partners. Communication was key. We had to deal with the county, contract administration, Sierra, the contractor, ourselves, and everybody really had to be on the same team with a cohesive goal of ensuring that this project was delivered at minimal impact. At the end of the day, that was achieved through effective communication, clearly laying out our expectations frequently and often, preemptively identifying risks as previously discussed, and adaptive management strategies. This is certainly an example of no one-size-fits-all solution, and adapting quickly and dynamically to changes in the environment and the construction schedule were absolutely critical in delivering this project at the end of the day. At the end of the day, it's a project I was thrilled to be involved with, a little daunting to begin with, but I'm really happy with our outcome, and I think everybody, project partners included, can be really happy with the success that we achieved on the outcome of this project. And with that, I will open for questions.
Thank you very much.
Thank you.
As a long pointer that crosses the causeway a couple times a day,
Yeah.
I have to say it was an amazing project to watch, and people were trained.
Yep.
Yeah, on the cruise, and even the grumpy long pointers were happy with the bridge.
Yes.
So that's a miracle.
Yeah.
Any questions from the audience?
Well, I really appreciate your presentation, and I was wondering if you could explain a little bit further what the cost was of all the extra work that you did for environmental protection, what was necessary in this case, but what added to the overall cost, I would think. So maybe.
It's a challenging question in terms of overall budget, but I believe in terms of the tender process, kind of absent or exclusive of delays or additional costs associated with the work as it occurred. From the outset, I believe the environmental budget was somewhere around $500,000 for specialty environmental services alone. Yeah. So, and again, all the credit to Norfolk County in being very proactive in getting ahead of this project. Often environmental protections are seen as, I don't want to say a necessary evil, but they're very often an afterthought, and the primary goal is delivering a project on budget and on time. But in this case, we saw that protection moved to the very top of the list, and it was a very refreshing take for a municipality coming from a consultant.
Mm-hmm. And also, how much extra time, from beginning to end, do you think it would have taken?
Well, the project, for various reasons, definitely extended beyond the original schedule. How much of that is related or directly attributable to the environmental is hard to say versus the actual construction process itself. But I could tell you that we faced innumerable setbacks related specifically to environmental protection with the bridge itself. I would say on the order of several weeks to months in terms of adaptively managing those isolated work areas. They were very difficult to maintain. When we isolate a work area around an abutment, our goal is to remove every individual aquatic species from that area. It's obviously a very daunting task with deep water levels and fluctuating flows. But ultimately, I think, and again, this goes back to being an adaptive management strategy, we basically have to move with what works and quickly evaluate the validity of our solutions on site so that we can ensure that we're moving this project as far along as we can.
Very good, thank you.
Thank you.
Thank you very much, Gavin. You got the last presentation, but you really brought it home.
Perfect. Thanks so
Thank
much.
you, everyone.
Appreciate your time.
So that you thought that was it. Actually, one more person to just send you on your way. Gavin, thanks very much, and that was an excellent talk. I'm Tom Vaya, the chair of the Long Point Biosphere Reserve Foundation, and I wish firstly to thank all of the speakers, presenters, folks that prepared all of the presentations that are in the back room. It was an amazing day today. And I think I enjoyed it. I'm sure you all enjoyed it as well, but a lot of hard work, not only to prepare for today, but what underpins all of the work and research and discussions that were brought forward today. So I wish to recognize all of our presenters and speakers today, and let's give them a round of applause. An amazing day. So the day was, in the program was put on by the Long Point Biosphere. And we have a couple of organizers, many organizers, but a couple of organizers that really do all the heavy lifting to put this day together. And the two that I recognize, Cynthia Brink, who leads one of our programming areas around education, knowledge sharing, and outreach, and Sarah Kirk, who recently joined us and worked hand in hand with Cynthia. So they did all the heavy lifting today, and I'm sure there was many others, but we can give those two people a round of applause for their work and recognize, so thank you. So who are we? The Long Point Biosphere is recognized as a UNESCO biosphere since 1986. As a matter of fact, we'll be celebrating our 40th anniversary as a designated biosphere just in a couple of years, so it's pretty incredible that we've been around for such a long time. My role as chair and with the members of the board and others that participate are stewards of the biosphere today, and we're just in line behind others that have done this great work over 4 decades and in front of others, some of which who could be sitting in the room, who will continue to be stewards of this biosphere as we look into the future. Like every conference we do, there's some provocative discussions and things to think about. And, Peter Zuzik in the morning, in his opening talk, talked about not necessarily the threat of species at risk, but the threat of the biosphere itself, to the biosphere itself, and some of the things he talked about. So very provocative discussion. And then, we ended with the talk by Gavin, and just talking about species at risk and, the causeway itself. And then in between, we heard so many terrific discussions today about the biodiversity, about the conservation efforts that go on every day and have gone on for a long, long time. And so you can see how this all sews up together and why this is so important that we do this work and that we come out and we come together and we talk about this work and then we share it elsewhere. This is a very special place. It's a very unique place, and it's going to be these kinds of discussions and the outreach and the work that we all do that continues to bring attention to this amazing biosphere that we have. A bit of a pitch, as a biosphere, we're a working board, and we do have members. So if anyone does have interest in becoming more involved with us on a different level, we're always open to evaluating people that might want to join our working board. And we would love to have you as a member. So this will be outside, and you can scan the QR code and just become a member of the biosphere. And what that does is it gives you greater access and insight to the work we're doing. And there may be some other ways that you may choose to become involved on a less formal basis. So if you have interest in that, please stop and see Sarah Kirk or myself or anybody else, and we would love to talk to you about becoming a bit more involved with our biosphere. What we do, so who couldn't join an organization like this? Our mission is we collaborate to enhance ecosystem and community well-being and unite the people with nature. And our vision is all living things thrive here. So you'll never find a better organization to join than this one. I mean, that's an incredible mission and vision. And the work that we do falls into biodiversity and conservation, education and knowledge sharing, and sustainable community and tourism. Those are the main areas that we are doing our work today. So it's an amazing organization with incredibly dedicated people who give a lot of time to be sure that the good works of the biosphere continues to be front and center within the community, but even outside of the community. And you may have read that this year we were privileged to host Julie DeBrosen, and Julie is the Parliamentary Secretary to Environment and Climate Change Canada. And she came out, she spent a day with us. She met with a number of local organizations. Lauren helped her launch some turtles into the marsh. And again, it just brought tremendous focus on our Long Point biosphere. And with the relationship that we've now formed with Julie, it's given us access to some other parliamentarians. Even just this week, a couple of our biosphere members were in Ottawa for a day on the Hill and had the opportunity to represent our Long Point biosphere with some influential people in Ottawa, just to talk about what's happening here, and hopefully we can influence things that will allow us to get things done, and maybe raise funding and other things that we have to do to make this all happen. So that's who we are. We're really pleased that you came and spent your day with us today. I want to give a very big thank you to Kendall, Mike, and Verity from Norfolk County, from County Fork, in Port Rowan, who put on the amazing food and snacks and things that we had all day today. And also Dean and Phil from Maney Media. We were seamless today. You guys did an amazing job, so thank you for that. I think that's so important that we have a presentation. Other than the one person that was up here who had to fill the gap, and he talked about the smoke. What's your address again? Because that sounded pretty darn good, right? So it sounds great. So those are the thank yous to everybody, and again, a big thank you to you for being a part of our day today. A big thanks. And next weekend, you'll hear a little more about us. We have an event. Unfortunately, it's sold out, so this is not a pitch, but next Friday night at the Capitol 33 in Delhi, we're going to be releasing a feature film called A Priority Place. And it's a 70-minute documentary film about this biosphere in Norfolk County. And it's a tremendous accounting of what actually is going on here. So it's our film launch. Our film producer is going to be there that evening. It's a fundraiser for some of our education and outreach programs for youth. And we will find a way to get it out so that everyone can have the chance to consume this amazing documentary film on our special area. And again, unfortunately, it's sold out, which is, I shouldn't say unfortunately, it's a good thing. We're sold out. Unfortunately, I can't sell you some tickets, but we'll be sure that that's out. And if you're tracking us, if you're following us on social media, or watching us on the website, we will have an opportunity where everyone can have a chance to view this film. So another big event coming up next Friday night, and also led by Cynthia, with the support of our Priority Place partners and Environment and Climate Change Canada, who are very big supporters of ours here at the Biosphere. So with that, I'm going to end the day. Thank you very much. Get home safe, enjoy your weekend, and have a fabulous barbecue and birthday. So, thank you. What do you need, Cynthia? Oh, we're going to see the film. The teasers from the film. Okay.